All right, let's dive right in. If you're building any kind of modern system, you've probably hit this question: Kafka or RabbitMQ? It's a huge decision, right? Today we're going to break it all down. What makes them tick, where they really shine, and how you can pick the absolute right nervous system for all your application's data.
Okay, let's get one thing straight right off the bat. If you're thinking of Kafka as just another message queue, well, you're missing the entire point. It's a totally different beast. It wasn't built just to send messages from A to B. Nope, it was designed to be a permanent, replayable record, literally a source of truth for your whole data ecosystem. So, to really wrap our heads around this, we have to understand what Kafka is at its core. And it's not a queue. It's a distributed event streaming platform. Or, to put it even more simply, it's a distributed event log. So, what on earth does that actually mean? Let's break it down.
Okay, this right here is the absolute key difference. Picture this. A traditional message broker, like RabbitMQ, is basically a post office. A message gets delivered to a mailbox, someone reads it, and poof, it's gone. But Kafka? Totally different. Think of Kafka like an old VCR tape. Events are recorded in order and they just stay there. Anyone can come along, watch it, rewind it, watch it again from the beginning, and it doesn't erase the tape for anyone else. That's the magic. The message isn't deleted just because someone consumed it.
In that VCR tape we were just talking about, that's what we call an append-only log. It's a really simple idea, but it's incredibly powerful. Every new event just gets tacked onto the end. That's it. The log is immutable, which is a fancy way of saying you can't go back and change the past. And this is the secret sauce behind Kafka's durability. It's why different systems can all sip from the same data stream at their own speed, or even decide to go back and reprocess everything from the very beginning.
You know, this whole append-only log design is exactly why Kafka is such a beast at scale. It gives it some, frankly, incredible superpowers. We're talking massive, massive throughput, because just writing things one after another to a disk is crazy fast for a computer. It scales out horizontally, which just means you throw more servers at it to get more power. And since every message is written to disk and copied across a bunch of machines, it's super durable and fault-tolerant. You'd have to try pretty hard to lose data.
Okay, so the theory is cool and all, but where is the rubber actually meet the road? Let's take a look at how this architecture translates into some seriously powerful real-world use cases for Kafka.
All right, first up, probably the most fundamental use case of them all: building real-time data pipelines. The easiest way to think about this is to picture Kafka as the central nervous system, or maybe the main data bus for an entire company. So what makes it so good for this? Well, Kafka can just drink from the fire hose. It can suck in massive streams of data from literally everywhere: your apps, your databases, IoT sensors, you name it. And then it makes all that data available super reliably to any other system that needs a piece of it. It doesn't matter if it's a giant data warehouse or a live, real-time dashboard. Kafka is like the universal translator and transporter for all your data. Next up, and this is a huge one for anyone building modern systems: event-driven microservices. You know the deal. The whole idea is to stop services from having to make those brittle, direct calls to each other. Instead, they just communicate asynchronously. They shout events into the void and listen for events to care about. And this, right here, is a total game changer. Kafka acts as that void I mentioned, completely decoupling all your services. So your ordering service, it doesn't need to know if the shipping service is even online. It just publishes an order-created event. That's it. The shipping service can pick it up now or in an hour, whenever it's ready. And that creates a way more resilient and scalable system. Okay, now we're getting into something really, really cool: stream processing. This is where we go way beyond just moving data from point A to point B. We're talking about processing, transforming, and reacting to data as it's flowing through the system, in real time. I mean, think about a ride-hailing app, right? It's getting a constant flood of GPS data from all its drivers, and at the same time, a flood of ride requests from users. By using something like Kafka Streams, it can actually join those two fire hoses of data together in real time to find the perfect match. That's the power of processing data while it's still in motion. This next one is a classic. It's actually how Kafka got its start back at LinkedIn. In any big distributed system, you've got maybe thousands of services, and they're all spewing out logs and metrics constantly. So the question is, how do you possibly make sense of all that noise? Well, Kafka gives you a single, centralized, high-throughput pipeline to pull all of that operational data together. So instead of every service writing to its own little log file or database, they all just publish to a Kafka topic, and suddenly your monitoring platforms have one single, reliable fire hose of data to drink from. This makes things like real-time alerting and deep analysis so much easier.
And finally, we've got a more advanced pattern, but it is incredibly powerful. It's called event sourcing. The core idea is this. Instead of just storing the current state of something in your database, like a user's current address, you store the entire history of events that led to that state.
And as you can probably guess, Kafka's append-only log is the absolute perfect backend for this. Every single state change, user created, address updated, order placed, is just an event that gets written to the log. What you get is a complete, auditable history of everything that has ever happened in your application. This makes debugging a dream, lets you rebuild state to any point in time, and opens up amazing possibilities for analytics on historical data. All right, so we've got a really good handle on Kafka's strengths now. With all that in mind, it's time to tackle the big question head-on. We know what Kafka is great for, but what about its main rival, RabbitMQ? When does it make more sense to use?
So when should you use Kafka versus RabbitMQ? Let's be super clear here. This is not about which one is better. That's the wrong question. It's all about picking the right tool for the right job.
This table really nails the key differences. Just look at the top. You've got Kafka as a distributed log, built for storing data long-term so you can replay it. And then you have RabbitMQ, a traditional broker built for messages that are here today, gone tomorrow. This fundamental difference points you straight to their best use cases. Kafka is for data streaming and analytics. RabbitMQ is for traditional task queues. So if your problem is handling a massive, never-ending stream of events you need to analyze, you're probably looking at Kafka. If your problem is more like, hey, I have a bunch of jobs that need to get done in the background, that is classic RabbitMQ territory.
And when we talk about raw speed, it's not even close. The difference is absolutely staggering. Just look at these benchmark numbers from Confluent. You've got Kafka over here pushing more than 600 megabytes per second. And RabbitMQ, it's clocking in under 40. That is a huge difference, more than 15 times faster. So if your whole world revolves around high-velocity data streams, this chart pretty much makes the decision for you. But wait, there's always a trade-off, right? When it comes to latency, RabbitMQ can actually be faster, but there's a huge if attached. Under light loads, yeah, it can hit a really impressive sub-1 millisecond latency, while Kafka is more like 5 milliseconds. But here's the kicker. RabbitMQ's latency falls off a cliff once you put it under serious pressure. Its smart broker gets overwhelmed. Kafka, on the other hand, with its simpler design, just keeps chugging along, maintaining that low latency even at a massive scale.
Okay, let's pull all of this together. What's the final takeaway? How do you actually make the right call for your next big project?
So here's the bottom line. Think of Kafka as your streaming data platform. It's a system of record built for durability, built for massive scale. On the other hand, think of RabbitMQ as your versatile message broker. It's fantastic at complex routing and distributing tasks. So if your problem is about streams of data, lean Kafka. If your problem is more about a to-do list for your background workers, RabbitMQ is probably your best friend.
And that really brings us to the final, most important point. Choose the tool based on your system design, not just because it's the new hot thing. You have to ask yourself one simple question. Am I building a durable system of record for a massive stream of events, or am I just building a to-do list for my services? If you can answer that question honestly, you will always make the right choice.